Okay. So 2 different trig functions on the left, 1 trig function on the right. Pretty safe bet you're going to have to do a substitution. So just keep that in mind. There are going to be some other times that you're going to see your notice or realize you want to do a substitution also. Okay? All right. Somebody talk me through this next one. What should we do first here? What do you think? Ethan?
Make that secant.
Why?
Is that an identity? 1 plus tan squared x equals secant squared x.
Oh, so you want to change that 1 plus tangent squared x to secant squared x. Okay, I thought you were saying change something to secant x.
No.
Okay, there's a difference in secant x and secant squared x. So, okay, so you're saying rewrite this. I misunderstood, but you weren't being clear either. Okay, so that's an identity, you're right. 1 plus tangent squared x is secant squared x. So that's just secant squared x, and then we're multiplying by cosine squared x. If you need to write the extra step of writing this as 1 over cosine squared x times cosine squared x, you can do that step. You need to if you need to see that. But if you can go straight from this step to realizing that that's equal to 1, I'm okay with that too, okay? Those are reciprocals. When we multiply reciprocals together, we get 1, okay? This guy's over there going, yep, okay. What are we gonna do on number 8? Who's got an idea for what we need to do there? Multiply. Multiply which side?
Don't you multiply the right side by 1 plus 1x?
Oh, I like that. Okay, this is the trick. This is like number 5. So more often than not, Sky, we want to look for the side that has the 1 plus the trig function or 1 minus the trig function in the denominator, and that's the side we're going to want to focus on. So that's why I was kind of hoping you were going to get to that. Okay, so yeah, let's multiply by 1 plus sine x over 1 plus sine x. Okay. So we end up with cosine x times 1 plus sine x all over, in our denominator we're foiling that out, and we end up with 1 minus sine squared x. And what is that equal to? Yep, there you go, that's right, Claire. 1 minus sine squared x is an alternative form to Claire's identity. That is just cosine squared x. And I'm seeing that we have 1 cosine as a factor in the numerator, and I have 2 in the denominator, so this simplifies to just 1 plus sine x over cosine x, and that's what we wanted. Look how awesome these work out when we've got a few brains working together, right? Okay, questions or comments on that one? Roman?
Could you just change the 1 minus sine x at the beginning?
To what?
Cosine x? Well, no, you can't.
Oh, it's not squared though. It's got to become squared before you can switch it to cosine squared. Okay? Yep. Okay. All right, number 9. What are some thoughts or ideas on this one? Okay, Claire's seeing that cotangent, so she's saying let's change that. Okay, I'm going to kind of do 2 steps in one here, okay? Because first thing I want you to notice is that we have a common denominator, and in this case our final answer has 2 terms, So it's highly likely probable that we want to break this up and do this term over our common denominator plus this term over our common denominator. So I'm going to do I'm going to kind of do 2 steps in one here. I'm going to rewrite this as sine x over cosine x plus, I'm going to rewrite that cotangent, that's what Claire was suggesting, over that common denominator of cosine. So I get cosine x over sine x all over cosine x over 1. All right. Now what? Lily, what does this give us? The sine x over cosine x. What is that?
Cotangent,
Careful.
tangent.
Yep, there we go. So that gives us tangent of x. For this, we've got to do keep it, change it, flip it. So we keep this the same. We change to multiplication and we are flipping this. And what's 1 over sine x equal to? Mason? Cosecant x. And that's what we're looking for, isn't it? Booyah. Isn't that nice? Not too bad, huh? Okay. These next on page 7, they get kind of complicated. All right, so questions on this one before we move on? Okay. We're not going to look at number 1. That's going to be part of what I'm going to assign for you to do. And we'll see where we are time-wise. I want to start with number 2, and we're going to kind of go from there. I've kind of got some other little hints and tricks on some of these problems that I want to share with you guys. So this is the classic example. Somebody in my 3rd period class said, why do we have to work with the more complicated side first? And so this is the problem I showed him. And I asked him, I said, well, what do you want to do with the left-hand side? And he's like, well, rewrite in terms of sines and cosines. And I was like, okay, but that's all you can do, right? That's it. And if you rewrite in terms of sines and cosines, you're putting it into fractions. And remember, when we were trying to simplify, we wanted to get rid of the fractions. So it's highly probable we want to try to get to that again, right? So it makes more sense to do all of this crazy work over here on the right-hand side and then get it to clean up to that nice, pretty -2 times cotangent x. Okay? All right, we have fractions. We are trying to subtract. So we need what? Ruh-roh. What do we need when we're subtracting fractions? Common denominator. Yes, thanks, Ethan. So we've got to multiply by 1 plus cosine x times 1 plus cosine x here. And here we've got to multiply by 1 minus cosine x over 1 minus cosine x. All right, so we're going to have to do some distributing here, aren't we? Okay, so I'm multiplying this sine times each of those terms. So think about what we get. We get sine x minus cosine x times sine x. And then we have minus this whole quantity. And we're over our common denominator, which if we FOIL that out, we're going to have 1 minus cosine squared x. So we'll get to that in a minute. But let's look at what we get when we distribute here. So when we distribute on that in that second fraction, we get sine x plus sine x cosine x. But we've got to distribute that negative, so we're going to deal with that. Now, I'm also seeing something else. What do you notice about this term and this term? They are the same. They're flipped in terms of the order, but they do mean the same thing. So let's think about that too. All right, so we have sine x minus cosine x times sine x minus sine x. And then distributing here, we get minus, I'm going to flip this just so that you can see that they are the same thing. And then our denominator is equal to what, Jacob?
Wouldn't it be
Sine
x?
squared x, right? Good. Okay. All right, so what do we notice happens in the numerator? Those two add to 0. But these two combine to give us a negative 2 times cosine x times sine x all over sine squared x. Now what? Yep, we've got signs that can cancel out or divide out, so that divides with one of those. And we have negative 2 times cosine x over sine x. Man, how pretty is that? Isn't that awesome? All of that stuff that just combines together so nicely. Okay. All right. Questions on that one? Or comments? Thoughts? No? Okay. I think when I originally did this problem on my paper, I want to go back and look. Yep. Yeah. So that's the thing too that you've got to realize is that, like, I solved this problem by rewriting. I saw a whole bunch of different trig functions. So my first thought on this one was to rewrite in terms of sines and cosines and just try to clean things up. But I see something else that if you guys can pick up on, makes things so much easier. So I want you to notice that we have a common factor in each term that we can factor out. So if we factor out the common factor, we are going to factor out a cosine x tan x. And then we need to think about what we're left with there. So cosine x times tan x times what to get this whole expression? What's missing from there? Morgan, what term do we need here so that if we were to multiply this, we would get all of that? There you go, secant squared x. And then minus, okay, now we're multiplying cosine x times tan x. We've got to figure out what we've got to multiply in order to get cosine x tan cubed x. So what would that be? Sydney? So we have the cosine. Yeah, there you go. You don't sound too sure about that, but that's right. It's tangent squared, right? If we multiply cosine x times tan squared, we're going to get this cosine x tan cubed. All right. Yeah. How pretty is that? It's a beautiful shade of green, isn't it? All right. I'm being a little bit snarky there, but guys, the reason why this is so pretty, what's secant squared x minus tangent squared x equal to? 1. So we are left with just this cosine x times tan x. And we got to clean that up, but that's pretty easy to clean up, isn't it? Right, so cosine x times 1 times sine x over cosine x. And boom, we've got sine x equals sine x. Okay. I promise you that that method, if you can see it, was a lot faster and easier than what I did. Because what I did when I was rewriting in terms of all of the sines and cosines was very involved. All right, we are going to look at number 5, and then I am going to I'm going to explain what I want you guys to do. All right, I need you to notice a couple of things. Let's play the game from Sesame Street. One of these things is not like the other. Which of the 4 places that we see there, which one looks different from the others and why? I'm sorry? Yeah, I see something squared. I'm seeing tans and cotans. Those are kind of similar. But then we have this cosecant squared. So that's kind of glaring at me, right? All right, we're going to do a substitution. How can we rewrite that cosecant squared using a Pythagorean identity? Whose identity is that? I think that's Sheridan's. Whose identity? Is that your identity? Did you have an identity?
I did. I don't know which one it was, but.
It was the last one. So,
1 plus cotangent squared x equals cosecant.
Yeah, there you go. 1 plus cotangent squared x equals cosecant squared x. Put you on the spot. You came through. Thank you. Okay, so I want to do a substitution. I'm going to substitute 1 plus cotangent squared x in place of this cosecant squared x. Okay, so I have 2 minus and then this we're going to keep down there just for now. We'll get to that in just a second. But we've got to distribute that negative, right? So we get 2 minus 1 minus cotangent squared x Okay, take a look at that. What do you think? So far, so good? Okay, now what? And no, we cannot just divide out the cotangent squared x over the cotangent x and say we have cotangent x. That's not legal because we have that other stuff that's getting added and subtracted to it. But we can factor the numerator. Think it would help to put a little note there about what you're doing. That's a difference of 2 squares. So how does the numerator factor? What's the square root of the first term? 1. Good. And the square root of the last term is cotangent x. And one's positive and one's negative, right? And then we have our denominator. So what do we notice that happens there? Yep, this divides out, doesn't it? And so on the right-hand side, we are left with just 1 plus cotangent x. I want you to go over to this left side. It's not ideal if you're working on both sides, but in this case, I think it helps to kind of do that and you can kind of see where we should be going. At least I hope you can. What should we do on that left-hand side? Who's got an idea?
Cancel the 10.
Okay, we can't just divide out initially. What do we have to do first? We have to break it up so we have our common denominator, right? So you're on the right track, Carly, you're right. But we definitely do, we have to break it up first. So we have to say tan of x over tan of x plus 1 over that tan of x. We have our common denominator, we can break it up and put each individual term over that common denominator. And that does give us then 1 plus cotangent x, which is what we were looking for. Boom. Guys, I hope you have noticed on every single one of these problems, the last step that you should be writing is that the left-hand side equals the right-hand side. So that needs to be the last step that you write on every one of these. Okay? All right. So here's what I would like for you to do. Alec and Claire, you guys can work together. So how many groups do I have? 1, 2. Okay, I'm gonna move this so we have a little bit more space. So what I would like for you to do is you are going to try number 1 and number 3 on page 7 for me. No, hold on, just a second. Okay, page 7, I want you to try number 1 and number 3. I will tell you that number 3 is really tricky. You're going to want to, I'm going to give you a hint to get started. You're going to want to multiply by the conjugate. It's pretty involved. Do the best you can with it. If you get stuck, try a little bit longer, but then if you get stuck and you get too frustrated, then move on. What I would like for you to do is I'm going to kind of make a list here of what I want you to look at. If there were any problems that anybody had trouble with, you need to fess up with your partner and go back and look at page 9 and rework any of those. Okay? Then I want you to try those 2 problems. Your homework for tonight is on page 10. So no, I lied. I'm getting myself confused, and I want to make sure I'm saying this correctly because I changed it. Yes, your homework tonight is on page 10. It's because I changed it, so I wanted to make sure I was telling you correctly. So try any problems on page 9 that you feel like you need to work through again. Then I want you to try these 2 on page 7. And then I want you to look at page 10 and kind of start working through some of those, okay? You're going to do these